So we have in the matrix format x of 0 to x of 3. And I return this is x of 0 to x of 3, which is the output of DFT, and these are the input samples from x of 0 to x of 3 with the matrix for the dual factor. This is also called as a characteristic or system matrix. Here we have the x of 0 to x of 3 with this, and this is for the IDFT. So for 8-point DFT, that means for n equals to 8, we have the W8 raised to 0, W8 raised to 1, 0 into 1, W8 raised to 0 means all here 0 into 7 means W8 raised to 7, and here we have till W8 raised to 7 into 7. This is the characteristic matrix for 8-point DFT with these values. So these values are calculated using the matrix method by putting the dual factor values for n equals to 0 to n minus 1 and for k equals to 0 to n minus 1. The first step of process of decimation is splitting a sequence in smaller sequences. So decimation means division of sequences. So first you have to decimate the sequence into smaller sequences if you have the longer sequence. Sequence of 15 can be splitted in 5 sequences of 3 or 3 sequences of 5. Each sequence of 8 can be splitted in 2 sequences of 4. There can be various combinations and varied complexities. So this is the 4-point DFT. X of 0 to x of 3, x of 0 to x of 3 is to be multiplied with the matrix for the dual factor. So after getting the matrix multiplication, we have the decimation of 4-point DFT into 2 radix 2 DFTs. So here is the x of 0, x of 2, x1 and x1, x of 3. That means if you have the sequence x of n having 4 number of samples, that 4 number of samples to be divided into even number samples and odd number samples. So we have x of 0, x of 2 and even number samples, and x of 1 and x of 3 are the odd number of samples. So at the first dual factor, after the first stage, we have x of 0 plus x of 2, x of 0 minus x of 2. So x of 0 plus x of 2 means here this x of 0 and this x of 2 gets added, and this is minus 1. So x of 0 minus x of 2 is here at the output of the second point. Similarly, here we have x of 1 as it is, and x of 3 is to be added with the x of 1. And here x of 1 is taken as it is, and x of 3 is a minus, means subtracted from the x1. Like this way, here we have the second stage of the DFT calculation. We have the w raised to 0, w1, w2, w3, which are the multiplication factor, dual factors coming by the formula at these points. And these values for this w4 raised to 0, 2, 1 and 3 are like this. W4 raised to 0 is 1, W4 raised to 2 is minus 1, W4 raised to 1 is minus j, and W4 raised to 3 is plus j. Like this way, we have by multiplication, here we have x of 0, x1, 2 and 3, which is not a shuffled order. But at the input, we have the bit shuffled order or bit reverse order. And here, there is no bit shuffling or bit reverse at the output of the DFT, Radix to DFT FFT algorithm. So this is the block diagram for the Radix to FFT algorithm. N by 4 point DFT even, and this is the n by 4 point DFT odd. So even and odd number of sequences are sampled, and we will have the output the same thing. So this is for n equals to 8. Radix 4 DIT FFT algorithm. Radix 4 means here 4 number, if you have the more number of samples, means x of 0 to x of 7, total 8 number of samples. All samples are to be divided into even numbered and odd number of samples. In the even number we have x of 2, x of 0, x of 2, x of 4, x of 6, and in the odd x of 1, x of 3, x of 5, x of 7. So these are the two parts given to the two separate DFTs, n by 2 point DFTs, and we have this at the output. And then by the using the signal flow graph, we have the x of 0 to x of 7 in the calculation. So these are the calculation methods which are shown here. So this is a diagram for n equals to 8 Radix 2 DIT FFT algorithm. Radix 2 means base is 2. So this is again the same diagram, but here the complexity is not increased. How to find out the values? That is shown by the dots. X of 0 here, this gets multiplied, this will come here, it will come here, and then at the end x of 7. So we have the at the output which is related with the x of 0. Like this way we have the signal flow graph for the endpoint DFT algorithm. So take a pause and draw the signal flow graph for n equals to 8 point, that is 2 DIT FFT, in your course journal. Thank you and all the best.